Alright, for our first question from Permutations, chapter 10.6, that's an easy difficulty. I've created a problem. Alfred, Betty, and Carol are in a race. How many ways can they rank in first, second, or third? Now there's a formula for this, and it's a fairly intuitive formula, but I want to show you the decision making that goes into that formula. First, we need to think permutations are all about decisions and choices. We have to decide who's going to be first. How many choices do we have? Then we have to decide who's going to be second. How many choices there? And likewise for third. So for this problem, I'm going to write A, B, and C. Okay? Again, this is my first place winner. So assuming that Alfred comes in first, that was a choice. Assuming Betty comes in first, that's another choice. And assuming Carol comes in first, that's another choice. Total of 3 choices. Now, at each choice, I have 2 different options. If Alfred comes in first, either Betty or Carol can come in second. Likewise, if Betty comes in first, then either Alfred or Carol can come in second. And if Carol comes in first, then Alfred or Betty can come in first. Or second, excuse me. And once I have those 2 decisions, notice that each one had 2 more choices after the first choice. I only have one option. If Alfred is first, Betty is second, then Carol must be third. And likewise, all these decisions are made for me. And that's for third place. So total I've got ABC, ACB, BAC, BCA, CAB, and CBA. And there's no way that you can list 3 letters differently. They're all there. And each one of these choices was 1 less than the last. Well, that's the factorial. So the answer is 3 factorial, which is 6. And in general, that's true. If I have 5 people racing, and I want to know how many ways those 5 people can come in first through 5th place, it's going to be 5 factorial, or 120. Okay, because at each step, I count the number of choices I have when I make a given decision. All right?